Okay, this is going to be interesting. So a guy comes into our shop the other day and says, "Hey, I'd like to get somebody to make some parts for my saw." So I was like, okay, well, typically we don't do that kind of stuff at our shop because we have, big vertical CNC machines that we do, tens and hundreds and thousands of parts on every day. So we typically don't do walk-in repair work. But I said, you know what, this looks like a cool job. I'll take it home and I'll play around with it, and I'll charge you probably almost nothing for it. It'll be a fun little thing for me to do at home. He's not really in a big hurry for it. So what we have here is these are parts for a feed mechanism hand wheel on a table saw or something. I'm not sure what the brand is. It's clearly made in China or some other country like that where you'd expect quality like this. And this is the hand wheel, and the problem that he's having is you can see this massive amount of play in here. So I have a couple ideas on how to solve that. The construction here is very flimsy. There's a hardened bushing here that the shaft goes in. There's not very much play in that, but this is an aluminum casting and this is a hardened bushing, and what appears to have happened is there's just so much wear that's occurred in this joint here. So my thought is to I have found this piece of 4140, is take this area up here and sort of slot out a section and then make a mating slot here, place this block in, put some bolt holes, bore this out to mate very nicely with the shaft to give it almost a tight fit, and hopefully that will straighten everything out. This block of material is just some drop that I grabbed off the shelf at work, and it seems to be just about a perfect fit for what I need to do here. So this will give me an opportunity to just do, maybe an interesting setup or two, and just get creative with it, and hopefully give this guy something that's going to work for him. Here's the setup on the mill. I basically just clamp this in the vise. I have a block in the back clamping inside there. It's kind of hard to see. There it is. So that's just adding a little extra rigidity to this setup. We'll see. I'm not going to be doing a lot of milling here, but basically I'm going to mill a 3/4 inch wide slot the entire length, and it's only going to be maybe 50 thousandths deep. It's not going to be very deep. And then I'm going to drill and tap 2 holes, probably for some screw that I have, an 832 or a 1032, something like that. So the first thing I'm going to do is level this out and basically just make sure that it's fairly straight before I go milling through here. And then I want to center about this hole to cut my slot. So I'll zero out on that in my x-axis and then do the slot milling from there. So moving across here, it's actually not too bad. It's actually pretty even. It's just dipped in the middle. So I'll call that good enough. There's no sense in fussing with that. So we can pick up the center hole and then we'll start milling away. So that was just a test cut to see how rigid this was, and it's actually pretty rigid. I'm surprised. I only took maybe, I don't know, 20 thousandths deep. So I'm going to go to the full depth here, 30 thousandths, or I'm going to go about another 30 thousandths, take it down about 50, and then I'm going to set up an indicator over here against the part and dial in the sides of the slot to get the 750. So now I cut both sides of the slot. I can get a measurement, see where I'm at. I'm about 644. So I'll take about 53 off of each side and check it again and probably call it about done. So I just come in here, move my dial. There's 50 and 3. And over here we'll do the same thing. And now I'm right 751. So that's perfect. So now I'm going to see what kind of screws I want to use. They're probably going to be number 8s, and put some drilled holes in here and tap them for those screws. I'm going to go with 832 socket head cap screws because I have a bunch of them, like the one I just dropped on the floor. So I'm going to drill a through hole here and then a 1/2 inch past that, counter bore them, and we'll have to see how deep I need to go for the threads to get through here, but I'll probably end up counter boring them a little deeper than I normally would. And then finally a bore up on this end for a nice sliding fit with the worm gear here. So here is going to be the bore. I have the drilled and counterbored holes in. So I'm just going to drill it out. I think it's a 270 drill. And then I'm probably going to run a 375 reamer, or end mill rather, through there to get it close. And then the final bore is about 393 or 10 millimeters. It's a pretty far undersized 10 millimeters, which is why I think there was so much trouble with this assembly in the first place, because the shaft is a couple thousandths under the actual size of the bushing that it was in. So I think the tighter bore is going to help a lot. as with any boring bar setup, we have to try to make it interesting. Okay, so really we just have to try to make it work. So what I have here is I'm bored out to 375 with an end mill, so I'm sort of just setting the tool against there till it rubs, which is about where it is now. And then back here I have an indicator set to 0, so what I can do is after I bore it, it allows me to back off the tool in the Y direction so I can check the piece. So what I'll do is I'll bump out maybe 5 thousandths or so, take a cut, take a measurement, and see how the boring bar is performing. I'm pretty happy with the size that I got here. I'm actually really happy with it. The way it fits in is just, once you get it in all the way, there's absolutely no wiggle side to side, and rotationally it just seems to spin perfectly. So that's definitely good. What I ended up doing is taking a couple light cuts and then a spring cut or so, and just really taking some careful measurements and some really light cuts to bring in the final dimension. So I'm going to deburr this, and then we do have to flip it over to cut the sort of the key in to fit onto the housing. I have this assembled on here now, so you can see how it attaches with the 2 screws and then the bore. And so now, as I spin this, there's no play at all. Even the backlash is minimized slightly, and I basically got rid of this hardened bushing and replace that bearing surface with the 4140 pre-hard. So it's going to wear in eventually, but then I think with the minimal use that this guy is using this for, I think this is going to be great. So I'd call this done and a pretty successful